Hello students, welcome to our today's lesson. In our today's lesson, we will learn about molarity of the solution, molality of the solution, normality and mole fraction of the solution. At the end of this lesson, you will be able to define mole fraction, molarity, equivalent mass, number of equivalents, normality and molality of the solution. Calculate mole fraction, molarity, normality and molality of a solution from a given set of information. Molarity, denoted by capital M. Molarity of a solution is the number of moles of solutes in a given quantity of solution, in a given volume of solution. Therefore, molarity equal number of mole of solutes, divided by volume of the solution in liter. But number of mole of solutes equal mass of the solutes divided by molar mass of the solute times volume of the solution in a liter. Units of molarity is mole per liter, which is known as molar, capital M. For example, what is the molarity of a solution containing 0.32 moles of sodium chloride in 3.4 liters solution? Molarity of the solution, capital M, equal number of mole of solute divided by volume of the solution in liter. Number of moles of solute is 0.32 moles, equal 0.32 mole, divided by volume of the solution in liter is 3.4 liter. Now this is 0.94 mole per liter, which is known as molar, capital M. Example 2, calculate the molarity of a solution made by dissolving 23.4 gram of sodium sulfate in enough water to form 125 milliliter of solution. Molar mass of sodium sulfate is 142 gram per mole. Let us do together. Molarity, capital M, molarity of the solution equal number of mole of solute divided by volume of the solution. But number of mole of solute is mass of solute divided by molar mass of the solute times volume of the solution in liter. Mass of solutes is 23.4 gram, 23.4 gram of sodium sulfate, 23.4 gram, divided by molar mass of the solutes is 142 gram per mole, 142 gram per mole, times volume of the solution in liter. 125 milliliter is volume of the solution. You have to convert it into liter, because the units of molarity is mole per liter, which is known as molar. 125 milliliter is the same as 0.125 liter. This equal 1.332 mole per liter, equal 1.32 molar. Molality, denoted by the symbol small m, molality of the solution. Molality of the solution is number of moles of solutes per kilogram of solvent. Therefore, molality small m equal number of mole of solutes divided by mass of solvents in kilogram. Mass of solvent in kg in kilogram. Number of mole of solutes is mass of solute divided by molar mass of the solute times kilogram of the solvent. Kilogram of the solvent or mass of the solvents in kg. The units of molality is mole per kg, which is known as molal. Units of molality is mole per kg equal molal, small m, molal. For example, what is the molality of a solution containing 0.46 mole of solids in 2 kilogram of water? You are asked to calculate molality of a solution. One way of expressing concentration of a solution is using molality. Therefore, molality small m equal number of mole of solutes divided by mass of solvents in kilogram. Kg of solvents, kilogram of solvent. Number of mole of solute is 0.46 mole, 0.46 mole divided by kilogram of solvents in 2 kg of water, 2 kilogram kg. 0.46 divided by 2 is 0.23 equal 0.23 molal. 0.23 molal is molality of this solution. Example 2. A solution is made by dissolving 4.35 gram of glucose in 25 milliliter of water at 25 degrees centigrade. Calculate the molality of glucose in the solution. Water has a density of 1 gram per milliliter. What do? You are asked to calculate molality of this solution. Now, molality, small m, molality of the solution, molality equal number of mole of solutes, divided by kilogram of the solvent, kg of solvent. But number of mole of solutes is mass of the solute, divided by molar mass of the solute times kilogram of the solvent, kilogram of the solvent. Now molality, small m, equal mass of solute is 4.35 gram glucose, 4.35 gram glucose divided by molar mass of glucose, is 180 gram per mole, 180 gram per mole times mass of the solvent in kg. Here what is given? Volume of water and density of water is given. We can calculate mass of water from density and volume. Density by definition, density of water equal mass of water divided by volume of water. From this mass of water, H2O, equal density of water, which is 1 gram per milliliter, 1 gram per milliliter times volume of water is 25 milliliter, 25 milliliter. This will be cancelled by this. We are left with gram, which is the units of mass. Therefore, mass of water is 25 gram. 25 gram. Note that for dilute aqueous solution, if density of the solution is 1 gram per milliliter, 1 milliliter is approximately equal to 1 gram if density is 1 gram per milliliter density. Therefore, mass of water is 25 gram, 0.025 kilogram. Molality equal 4.35 gram divided by molar mass of the solids 180 gram per mole times mass of the solvent in kg, which is 0.025 kilogram. Gram will be cancelled by gram. We are left with mole per kg, which is the units of molality. Now 4.35 divided by 180 times 0.025 is 0.97 molar. 0.997 molar is molality of the solution. Molality of the solution. Okay, normality denoted by capital letter N. Normality of the solution is number of equivalent of solids per liter of solution. Normality denoted by the symbol capital N. Normality equal number of equivalents of solids, number of equivalents of solids divided by volume of the solution in liter, volume of the solution in liter. Number of equivalent of solids equal mass of the solid divided by equivalent mass of the solid times volume of the solution in liter. We can write this as mass of the solid divided by equivalent mass of the solid is molar mass of the solid divided by Z. Molar mass of the solid divided by Z times volume of the solution. Here Z for an acid is number of hydrogen ions released by 1 formula unit of the acid. For a base, Z is number of OH minus furnished by the given base. For a salt, Z is total positive valency. For oxidation reduction reaction, Z is total number of electrons gained or released by the given reaction. Therefore, normality of the solution equal M times Z divided by molar mass times volume of the solution. This can be written as mass divided by molar mass is number of mole of the solids, small n times Z divided by volume of the solution. From this, number of equivalents of solids equal number of mole of solid times Z. Number of equivalents of the solid equal number of mole of the solid times Z. What is the relation between normality and molarity? Normality equal number of mole of solid divided by volume is molarity of the solution. This is molarity of the solution. Therefore, normality equal N divided by V is molarity. Molarity capital M times Z of the solution. This is the relation between normality and molarity. Normality equal molarity times Z. Molarity times Z. For example, calculate the normality and molarity of a solution that contains 16.2 gram of the salt iron sulfate. Molar mass of iron sulfate is 400 gram per mole in 200 milliliter solution. You are asked to calculate molarity and normality of this solution. Normality, solution. Normality equal number of equivalents divided by volume of the solution. Therefore, normality equal M times Z divided by molar mass times volume of the solution. mass of the solute times Z divided by molar mass times volume of the solution equal small m is mass of the solute, which is 16.2 gram, 16.2 gram, times Z for a salt is total positive valence. The salt is iron sulfate. Total positive valence of iron, its valency is plus 3. Here we have 2 iron atoms. Therefore, total positive valence is 6. For 1 iron, the valency is 3. For 2 iron, the total is 6. Therefore, 6 equivalent per mole, divided by molar mass of the solute, molar mass of iron sulfate, which is 400 gram per mole, 400 gram per mole, times volume of the solution in liter. Volume of the solution is 200 milliliter. This must be converted into liter because the units of normality is equivalent per liter. 200 milliliter in liter is 0.2 liter. Gram will be cancelled by gram. Mole will be cancelled by mole. We are left with equivalent per liter, which is the unit of normality. Therefore, 16.2 times 6 equivalent divided by 400 times 0.2 liter is 1.215 normal, 1.215 equivalent per liter, which is normal, 1.215 normal. What is the molarity of this solution? As we said, the relation between normality and molarity is this: normality equal molarity times Z. From this, molarity of the solution equal normality divided by Z. Normality of the solution is 1.215 equivalent per liter, 1.215 equivalent per liter divided by Z is total positive valence, which is 6 equivalent per mole. 6 equivalent per mole. Equivalence will be cancelled by equivalent. We are left with mole per liter, which is the units of molarity, is molar. Therefore, 1.215 divided by 6 is 0.203 molar. 203 molar is molarity of this solution. Mole fraction denoted by this symbol, mole fraction. If the solution has a solvent and the solids, a mole fraction gives a concentration at the ratio of moles of one component to the total moles present in the solution. If a solution contains solutes and a solvent, then mole fraction of the solute, mole fraction of the solute equal number of mole of the solute, divided by number of mole of the solution, Mole fraction of the solvent, equal number of mole of the solvent, divided by number of mole of the solution, Note that number of mole of solution is the sum of number of mole of solute and number of mole of solvent. Mole fraction add up to give 1. Therefore, mole fraction of the solute plus mole fraction of the solvent equal 1. For example, 1 mole of alcohol is mixed with 3 moles of water. Calculate the mole fraction of alcohol and water. You are asked to calculate mole fraction of the solids and mole fraction of the solvent. Let us do together. Solution. Mole fraction of the solid, mole fraction of alcohol equal number of mole of alcohol divided by number of mole of solution. Number of mole of solution. Number of mole of alcohol is 1 mole. 1 mole divided by number of mole of solution. Number of mole of solution is number of mole of solids plus number of mole of solvent, which is 1 mole plus 3 mole is 4 mole divided by 4 mole. 4 mole. Mole will be cancelled by mole. Therefore, mole fraction has no unit. 1 divided by 4 is 0.25. 0.25. This is mole fraction of alcohol in this solution. What is the mole fraction of water? Mole fraction of the solvent. Mole fraction of water. Mole fraction of water equal number of mole of water. Number of mole of water divided by number of mole of solution. Number of mole of solution. Number of mole of water is 3 mole. 3 mole. 3 mole divided by number of mole of solution is number of mole of solid plus number of mole of solvents, which is 1 plus 3 is 4 mole. 4 mole. Mole will be cancelled by mole. 3 divided by 4 is 0.75. Mole fraction has no unit. You see, mole fraction add up to give 1. Mole fraction of the solid plus mole fraction of the solvents equal 1. Mole fraction of the solid alcohol is 0.25 plus mole fraction of the solvent is 0.75 equals 1. Students, let us do this question so that you can practice what you have just learned. You have 2 minutes. Good. How did you do it? Let us do together. What is the mole fraction of a solid in 1 molar aqueous solution? What is the mole fraction of a solid in 1 molar aqueous solution? mole fraction of the solid solution. Mole fraction of the solid, mole fraction of the solid equal number of mole of solute divided by number of mole of solution, which is number of mole of solute, plus number of mole of the solvent. What is given? Molality of the solution. Molality of the solution is 1 molar. As we said, molality is defined as molality equal number of moles of solute divided by mass of solvent in kg, kilogram of solvent, kg of solvent, kilogram of solvent, which is 1 molar. 1 molar means 1 mole of solute is dissolved in 1 kilogram of solvent. 1 mole of solute, 1 mole of solute dissolved in 1 kilogram of solvent, 1 kg of water. 1 kg of water. Because the solvent is water, it says aqueous solution. Aqueous solution. From this, number of mole of solute is 1 mole. Number of mole of solute, equal 1 mole. Mass of solvent is 1 kilogram. Mass of water equal 1 kilogram. 1 kilogram. In gram, kilo is 10 to the power of 3. Therefore, this is 1,000 gram. 1,000 gram. You can calculate number of mole of water from its mass. Number of mole of water equal mass of water divided by molar mass of water. Mass of water here is 1,000 gram. 1,000 gram divided by molar mass of water. Hydrogen 2 plus oxygen 16 is 18 gram per mole. 18 gram per mole. 18 gram per mole. Therefore, number of mole of water equal 1,000 divided by 18 is 55.56. 55.56 mole. This is number of mole of water. Now, mole fraction of the solute. Mole fraction of the solute equal number of mole of solute. Number of mole of solute is 1 mole. 1 mole. 1 mole divided by number of mole of solution, which is the sum of number of mole of solute and number of mole of solvents. Number of mole of solute is 1 mole. 1 mole plus number of mole of solvents is 55.56 mole. 55.56 mole. Mole fraction of the solutes. Equal 1 divided by 1 plus 55.56 is 0.018. 0.018. Mole fraction has no unit. Students, in our today's lesson, we learned molarity of the solution. Molarity is defined as number of moles of solids per liter of solution. Molarity is one way of expressing concentration of a solution. Molality of the solution is defined as number of moles of solids per kilogram of solvents. Normality of the solution is number of equivalents of solids per liter of solution. Mole fraction of solids is number of mole of solids divided by number of mole of solution. Mole fraction of the solvent is number of mole of solvent divided by number of mole of solution. This brings us to the end of our today's lesson. Until next time, goodbye.